In today's video, we're going to be looking at a Year 8 topic, but it's also relevant for GCSE geography, maybe for EdXL or AQA. And we're going to be looking at the greenhouse effect. So I'm just going to run you through some of the processes of the greenhouse effect. So what we've got here is I've got a very excellent image of the Earth that I've drawn here. The green is obviously the land and the blue is the sea. And we've got the Earth and we've got the atmosphere. And within the atmosphere, what I've drawn are these little speckles, and they represent greenhouse gases. And we're looking a little while about greenhouse gases and what they are and what they do. But first of all, I'm going to talk you through the process of the greenhouse effect and what happens during that process from when we get our incoming solar radiation to how the heat is trapped in the Earth's atmosphere. So we're going to start up here with the sun. And as you can see, the sun sends its radiation towards the Earth, and that comes in, and this is important, that heat comes in as short wave radiation. And short wave radiation's got a lot of energy, it's got a lot of power. So what it does is it's able to get through the greenhouse gases. It's able to get through this layer of thick greenhouse gas because it's got a lot of power, because it's short waves of radiation. So it comes through the atmosphere, it's able to get through all of these particles, and it hits the planet. And what it does, it heats up, which is what my little stripy line is around the Earth. It heats up the planet, so it heats up the oceans and it heats up the land. So the more solar radiation that comes in from the sun, the more the planet is heated up, and the oceans get hotter and the land gets hotter. And it's important, I've got a little note at the bottom that it's important that we do have some of these greenhouse gases, because we need this heat to stay in. We need it here because we've got a planet that grows things, that it's got a weather system, etc. So we have to have that heat, otherwise we wouldn't be able to exist on the planet. So the way that the heat's trapped is through the greenhouse gases, and without those greenhouse gases, some of those greenhouse gases anyway, then all of the heat would escape and we wouldn't get any warming. So once that Earth has heated, some of it is absorbed, as I said, and some of it is then reflected back off the planet. Now, the important point is that when it's reflected off the planet, it changes from long wave radiation, which has got a short wave radiation, which has got lots of energy, and it changes to long wave radiation. And longer waves are slower and they've got less energy. So when they go back up into the atmosphere, that is when they're trapped by the greenhouse gases. They can't get out, or not all of them can get out. Some of them do, but because they've got less power or less energy, then some of them are reflected back and they come back down to Earth and they heat up again. And that heat stays within the atmosphere. Some of it does escape, some of the long wave radiation does escape, but quite a lot of it's trapped. Now, the more greenhouse gases we have here in the atmosphere, then the more of this heat will become trapped. So the more of the long wave radiation will become trapped, and then it will bounce, heat up the planet again, bounce off, get trapped again, bounce back down, heat the planet up again and again. So this heat will not escape. So what is happening with greenhouse gases is it's trapping heat like a greenhouse. If the sun shines on a greenhouse, then the glass will keep the heat in, and if you remove the glass, then the heat will escape. But the more greenhouse gases there are, then the less of that heat can escape. So greenhouse gases can be one of 4 different types. We're going to look at them. We're going to look at carbon dioxide, which very often comes from burning of maybe fossil fuels, burning of coal and oil. It can come from burning wood as well, or anything that we burn can release carbon dioxide. If it's got carbon in it in the first place, then through burning, the carbon will be re-released into the atmosphere. And that is in abundance in the atmosphere. And that's the one that we are contributing to by burning more fossil fuels for more energy. We've got more cars, we've got more industrial processes, etc. So lots of carbon dioxide in the atmosphere. We've also got nitrous oxide, and nitrous oxide comes from industry, comes from industrial processes, and it also comes from aeroplane fuel, burning aeroplane fuel. So the richer we are and the richer people get around the world, and the more nitrous oxide is released. The next greenhouse gas we've got is methane, and methane comes primarily from cows, and it comes also from rotting vegetation. So it comes from landfills, it comes from rice fields, etc. Anywhere where vegetation rots, we will release methane. So digging up the ground and taken peat out the ground in certain parts of the world, or where we've got in the northern latitudes where we've got the ice melting and permafrost melting up in the upper latitudes, then that will release methane as well. Now, nitrous oxide and methane, they are two very, very, very potent greenhouse gases, and although carbon dioxide is the most common of these three, it's actually nitrous oxide and methane that do the most damage, because they can hold kind of up to like 200 times more heat than carbon dioxide can. So methane and nitrous oxide, although they're not in the same amounts as carbon dioxide, they're really, really, really important in increasing the greenhouse effect. And the final gas that we've got in the atmosphere, which is generally quite a natural gas that we've had, well, they're all natural, but is water, H2O. So we've got water droplets in the atmosphere, and that's also a greenhouse gas. But we don't often hear about that, because in a lot of ways that's seen as more natural maybe than carbon dioxide, not nitrous oxide and methane. So all of these greenhouse gases can be natural, they can occur naturally in the atmosphere. Carbon dioxide can be released from burning wood, so forest fires, and that can be natural. So many thousands and millions of years ago, we still had greenhouse gases in the atmosphere even that long ago, and that was from the release of CO2 through burning of wood and things like that. Nitrous oxide can be natural as well. Methane can be because we respire, and animals respire, and vegetation rots. And like I said before, water droplets are in the atmosphere all the time anyway. Or they can be man-made. So as I said before, the amount of industrialisation that we've got, the amount of people on the planet, the amount of fossil fuels that we are burning increases carbon dioxide. The amount of nitrous oxide is increased by the amount of industry that we have, or the amount of planes that go up into the atmosphere. The amount of methane with breeding of cows, etc. And the growth of rice and things like that can release methane. And water, H2O, come from industrial processes where steam is released into the atmosphere, so additional water can be released. Also, the heating up of the atmosphere will mean that there's more evaporation, so maybe more water is actually in the atmosphere. We know that this is a closed system, but we can have more H2O in the atmosphere. So like we said before, just to recap, shortwave radiation comes from the sun. Because it's shortwave, it's got a lot of energy, it's able to pass through the thick layer of greenhouse gases. It hits the planet, heats up the planet. Some of it is reflected. Because it's now in a long wave form, quite a lot of it can't escape, so it comes back down and it reheats the planet. So the more greenhouse gases that we have, the enhanced greenhouse effect we often call it, that's where humans are adding to the natural greenhouse gases, then the more there are in the atmosphere, the more heat will be kept here, and the hotter the planet will get, and we'll actually have more global warming. Sea surface temperatures will get hotter, land will get hotter, and we have lots and lots of negative impacts to do with that, which will be in one of the subsequent videos.